It is rare for the universe to surprise us once, rarer still to surprise us twice. But when Atlas followed Oumuamua and Borisov into our neighborhood, it became clear this was no isolated curiosity. It was a sequence, a rhythm, and with it, suspicion began to deepen. Oumuamua in 2017 was the first whisper. A cigar-shaped enigma slipping past the sun, tumbling so oddly that models broke under its spin. More troubling was the acceleration, an invisible push, as though something beyond gravity nudged it along. Borisov, in 2019, seemed to restore balance, a classic comet with bright tail and jets, but still exotic for having crossed the void between stars. Two visitors, both remarkable yet together explainable. Then came Atlas in 2025, and with it, a fracture in our confidence. Not simply because it was the third, but because it refused to behave like either of the first two. Its path was sharp, angled, almost surgical. Instead of easing through our skies, it cut across like a deliberate incision. Its chemistry pushed credibility further. Carbon dioxide 8 times stronger than water vapor. In every comet studied within our system, water dominates. But Atlas reversed the script. The familiar became the exception, the anomaly the rule. Hubble saw it, Webb confirmed it. The Very Large Telescope traced the same imbalance. Different eyes, different instruments, yet the same result. And instead of clarity, certainty slipped further away. Was this simply the legacy of a birthplace, light years from our own, shaped in conditions we do not share? Or was chemistry itself being used as a message, a signature, etched into molecules, daring us to notice? Official voices reassured us. The press releases spoke of frozen gases, dusty cores, standard cometary behavior, but the phrasing wavered. Words like likely, possibly, consistent with. Gone was the confidence of absolute claims. Instead, a quiet humility emerged, as though the universe had forced even our most trusted voices to admit, we do not fully understand. 3 interstellar guests in less than a decade, each stranger than the last, each step pulling us further from comfort, deeper into doubt. Was it chance, or was it choice? That question lingered as astronomers plotted ATLAS's course across the solar system. Its trajectory wasn't chaotic, the way comets often are. Instead, it swept inward at a sharp angle, then bent around the sun with a precision that unsettled even seasoned orbital modelers. Comets, by nature, wobble. Their surfaces vent gas unpredictably, creating small pushes and jolts. Yet Atlas's path showed less deviation than expected, as though it were following a design more than random physics. No thrust was detected, no engine plume revealed, but the clean arc raised a quiet suspicion. What if control doesn't need to be obvious to exist? Of course, there are explanations. Its nucleus could have been unusually stable. Its venting might have occurred in balanced directions, cancelling out the usual cometary kick. Physics has tools for these possibilities. But as each explanation was proposed, another anomaly slipped in to erode it. Why did its stability persist across weeks of observation? Why did the curve of its orbit feel less like improvisation and more like choreography? The community reassured itself. NASA's bulletins stressed natural causes, citing cometary variability. Yet behind those bulletins, private conversations told another story. Paranoia wasn't spoken aloud, but it spread like a shadow. The dark forest theory was whispered in forums, in late-night calls between colleagues. What if interstellar objects are not simply wanderers, but scouts? Not threats in themselves, but signals of capability. Still, Paranoia is not proof. The scientific habit is to ground suspicion in data, so the numbers were checked again. Perihelion, 1.36 astronomical units. Relative velocity, 26 kilometers per second, a perfectly natural profile on paper. Yet numbers do not erase unease, they simply coexist with it. And so, scientists returned to the bigger frame. Oumuamua, Borisov, Atlas, 3 visitors, 3 anomalies. Was this simply statistics catching up with us? After all, the galaxy is vast, and stars shed fragments. Or was it a sequence, deliberately timed, arriving one after another in less than a decade, like knocks at a cosmic door? If it was chance, then our models of probability need rewriting. If it was choice, then the story is only beginning. If the story was only beginning, then telescopes would become its narrators. The first to catch Atlas was Pan-STARRS, the same survey that once found Oumuamua. Its wide field swept across the sky and flagged the faint dot moving against the background stars. Just another candidate at first, but within hours its speed betrayed its foreign origin. It was not bound to the sun. It had come from the dark between stars. From there, the handoff began. The Hubble Space Telescope locked on, its instruments slicing the faint light into spectra. Webb followed soon after, adding infrared vision sharper than anything we had before. Ground-based giants, the Very Large Telescope, Keck, Subaru, each took their turn. It became a relay, a chorus of machines staring into the same enigma, each hoping to find clarity the others had missed. What they found was not clarity, but dissonance. The chemistry leaned hard toward carbon dioxide. Water was faint, almost reluctant to appear. The coma stretched wide, dominated by CO2 jets, like a script written in the wrong alphabet. Astronomers had expected water to be the main voice, but instead it whispered while carbon dioxide shouted. The data should have settled the question. Instead, it unsettled it further, because every telescope agreed, and agreement left fewer places to hide. Was Atlas born in a colder cradle where carbon dioxide could survive in bulk while water locked deep inside? Or was something guiding what escaped? Selective, deliberate, like a code in exhaust. Even the language of science betrayed unease. Papers used cautious verbs, suggests, indicates, consistent with, words that tiptoe instead of stand, as if even the instruments themselves were humbled, reluctant to claim certainty. Telescopes became more than tools. They became characters in a drama, their silence heavy with unanswered questions. 3 telescopes, 3 continents, 2 points in space, all reading the same anomaly, all admitting in their own quiet way that ATLAS had broken the rulebook. Was it chemistry alone, or was chemistry just the disguise? The closer scientists looked, the more ATLAS seemed to be speaking in the language of chemistry. Carbon dioxide dominated every spectrum, almost 8-to-1 over water. Numbers like that aren't just odd, they're disruptive. They force us to reconsider the rules we thought were written into every comet. Most comets in our solar system are water-rich. Their tails gleam because sunlight turns ice to vapor, carrying dust with it. Carbon dioxide is present, yes, but as an accent, not the melody. Atlas flipped that script. Here CO2 became the main voice, loud and insistent, while water barely whispered. It was as if the comet had chosen to rewrite the songbook of its kind. Explanations surfaced quickly. Perhaps Atlas was born in an unusually cold nursery, far beyond the frost lines of another star. There, carbon dioxide could freeze in abundance while water stayed locked away, buried too deep to escape. A plausible story. But even plausible stories felt strained when placed against numbers this sharp. Why so much carbon dioxide? Why so little water? The Webb telescope added weight to the puzzle. Its infrared eyes confirmed the imbalance again and again. Agreement across instruments usually brings relief. This time it brought only deeper unease. Because if chemistry is the fingerprint of origin, then Atlas left us with a print that looked familiar enough to recognize but alien enough to distrust. Some whispered that chemistry was the trick, that natural processes might be hiding intent. Just as a stage magician uses ordinary props to conceal extraordinary methods, perhaps Atlas used ordinary molecules to veil an unnatural pattern. Nothing exotic, nothing that screamed technology, only ratios just wrong enough to stir suspicion. Science isn't comfortable with whispers, it prefers conclusions. Yet Atlas gave none. It gave ratios, numbers, lines on graphs, and then it left those numbers open, unfinished, waiting for us to decide what they meant. Was this simply ice from a cold, forgotten cradle? Or was it chemistry as code, intention buried in ratios? Oumuamua, Borisov, Atlas. 3 names that now sit together in our memory, like chapters of a story we didn't expect to be reading. Each arrival forced astronomers to stretch their definitions, to bend their categories, and to wonder whether the rulebook had ever been solid in the first place. Oumuamua was the first shock. In 2017, it slipped past, thin as a needle, accelerating in a way that gravity alone couldn't explain. Some called it a shard, some a sail, some even whispered artifact. Borisov followed 2 years later, and for a moment, it was a relief. A comet that behaved more like the ones we knew, icy, active, spraying dust into a tail. But its origin was still interstellar, and that alone kept the sense of strangeness alive. And then came ATLAS. In many ways it looked closer to Borisov than Oumuamua. It had a tail, it released gas, it seemed at least to fit the image of a comet. But once the numbers came in, it refused to behave. Its chemistry was off balance. Its orbit cut sharply across the system, like choreography written into the sky. Instead of calming the story, ATLAS disrupted it again. Patterns are how science survives. When we can find the repeating shapes, the shared fingerprints, we can start to trust that we understand. But with these 3 visitors, every pattern seemed broken the moment it appeared. Shape, speed, chemistry, each contradicted the last. If this was coincidence, it was piling up into something difficult to ignore. If it was chance, then chance was starting to feel suspicious. And so the comparison, instead of reassuring us, leaves us unsettled. Oumuamua bent physics. Borisov reassured us. Atlas bent chemistry. Each one gave us something new to explain, and each one left a different kind of unease in its wake. Together, they don't form a pattern, they form a warning. If there had only been 1 interstellar visitor, we could have called it rare. If there had been 2, we might have called it luck. But 3, arriving within less than a decade, begins to sound like rhythm. And rhythm is the first hint of design. Astronomers ran the numbers. The odds of 3 interstellar objects of this kind being observed so close together were vanishingly small. Our telescopes have scanned for decades without seeing any. Then, almost in sequence, they appeared. Oumuamua, Borisov, Atlas. Not scattered over centuries, but clustered within one human breath of time. Geometry made the puzzle sharper. Atlas's path sliced across the solar system at a steep angle, almost perpendicular to the ecliptic where planets and comets usually move. Oumuamua had also entered from a tilted direction, as if these visitors weren't simply drifting in, but arriving along paths we rarely see. each cut the sky in a way that looked more like placement than accident. Scientists reminded us space is vast, chance is strange, improbable things do happen. But their reassurances felt thinner with each arrival. Because what if this wasn't chance? What if what we were seeing wasn't randomness, but timing? A kind of cosmic choreography, each visitor following the last like notes in a larger score. In science, geometry is supposed to clarify. Orbits tell us about forces, alignments tell us about origins. But here, geometry only deepened the suspicion. 3 objects, each breaking different rules, yet all choosing to appear when our instruments were finally capable of noticing. Was the universe simply showing us its strange coincidences? Or was something choosing when to be seen? If suspicion begins with timing, it grows sharper when we remember who was watching. For centuries, the universe has sent countless objects past us, silent and unrecorded. But only now, with the most powerful instruments ever built, did we finally notice. Almost as if these visitors waited for our eyes to be ready. Oumuamua was caught by pan-stars in Hawaii. Borisov lit up lenses across the globe, its cometary tail stretching long enough to be obvious even to smaller observatories. And ATLAS? It fell under the gaze of Hubble, Webb, and the Very Large Telescope, machines so precise they could weigh chemistry from across millions of kilometers. Each telescope became a character in the unfolding story. Hubble, veteran of space, straining to capture faint streaks before its aging instruments gave way. Webb, younger and sharper, peeling back light into fingerprints of molecules. Ground-based giants like VLT, staring with their segmented mirrors, humbled by how little sense the readings made. The data was consistent, unnervingly so. Carbon dioxide swamped the signal. Water barely registered. Every instrument confirmed it. And with each confirmation, frustration grew. Because in science, replication should bring relief. Here, replication only brought discomfort. The more certain the measurements, the less certain the meaning. Astronomers spoke carefully. They called Atlas unusual, atypical, puzzling. But off the record, in quiet conference halls and private calls, they admitted something rarer, that Atlas was, in its way, humiliating. For decades, we had trained machines of extraordinary precision, and now, when they all agreed, they agreed on something we couldn't explain, and so the watchers themselves became part of the puzzle. Were our telescopes simply unlucky, catching anomalies by chance? Or were they participants in a script not of their own writing, tools summoned at the exact moment the cosmos decided to put on a show? When telescopes speak, they speak in light. Split that light, and it becomes a language of elements. Carbon, oxygen, water, dust. Normally the pattern is familiar. Water dominates, carbon trails behind. But Atlas inverted the script. Carbon dioxide surged ahead, water whispered faintly. The ratio wasn't balanced, it was overwhelming. Nearly 8 parts carbon dioxide for every 1 part water. On Earth, water is life's signature. In comets across our solar system, it's the baseline. To see it diminished so drastically, replaced by a flood of carbon dioxide, was like finding a book with all the vowels missing. The message remained, but the rhythm felt wrong. Scientists tried to explain. Perhaps Atlas was born in a colder nursery, where water froze so deeply it could not sublimate, leaving only the lighter gases to escape. Perhaps interstellar radiation locked the ice beneath a crust, forcing carbon dioxide to dominate. These were plausible ideas. They calmed the surface conversation. But beneath the calm, another possibility pressed forward. Because chemistry is not just a fingerprint, it is a behavior. And when that behavior defies every expectation, it begins to feel intentional. What if the imbalance wasn't accident, but message? What if the skew in Atlas's breath was its way of saying, I am not like the others? Here was the paradox. The facts were undeniable. Instruments agreed. The numbers stood firm. Yet certainty only birthed new uncertainty. Every ratio, every line of data pulled the object further from the natural and closer to the engineered. Scientists reminded us that nature is inventive, that chance can mimic design, and yet in the silence between their words, unease grew, because if chemistry is the fingerprint of origin, then Atlas left us with a print too deliberate to ignore, one that looked human enough to recognize but alien enough to distrust. Oumuamua was the first to bend the rules. It came without a tail, an interstellar wanderer moving faster than comets should, and then it accelerated as if nudged by something unseen. That mystery was enough to divide the astronomical community for years. Then came Borisov. Unlike Oumuamua, it looked familiar, icy, bright, a comet through and through. It reassured us briefly that not every visitor would be strange, that the universe still obeyed some of its old habits. Borisov became the control case, the example we could point to and say, interstellar objects can still be normal. But ATLAS? It arrived like a contradiction, too active, too carbon-rich, too unwilling to fit the categories we had built. Where Oumuamua challenged our physics, ATLAS challenged our chemistry. Where Borisov seemed to restore order, Atlas broke it again. The comparisons only deepened the discomfort. 3 interstellar visitors in less than a decade, each rewriting a different chapter of the rulebook. First motion, then appearance, then composition. The sequence looked less like random chance and more like escalation, as if each arrival was designed to test a different boundary of our understanding. Scientists, careful as always, reminded us that small numbers make bad patterns. 3 data points are not a law, yet the human mind resists randomness. We see rhythm in clouds, patterns in static, faces in the dark. And when the universe delivers 3 puzzles in such quick succession, suspicion is not easily quieted. So the question lingers, were we witnessing the messy diversity of interstellar debris? Or were we, unknowingly, watching a demonstration, one rule broken at a time, until we understood that rules themselves might not apply? If Oumuamua, Borisov and Atlas each broke a different rule, maybe the problem isn't with them. Maybe the problem is with the rules themselves. Science builds laws out of patterns, and for centuries those patterns have held. Water dominates comets, motion obeys gravity, chemistry falls into familiar ratios. But what if those patterns were never as universal as we believed? Each time we codify the universe, it seems to slip through our fingers. Oumuamua taught us that motion can defy expectation. Borisov reassured us, then reminded us that normality is fleeting. Atlas drove the point deeper, pulling chemistry out from under us. Together they ask a quiet, unnerving question. Are we describing the universe as it is, or only as we wish it to be? The irony is that science thrives on exceptions. Rules are not monuments. They are scaffolding, fragile until tested. And every time the universe sends a visitor that cracks our scaffolding, the discipline grows stronger. But strength does not erase the unease. Because 3 cracks in less than a decade feels like something more than happenstance. Some astronomers whisper that we are simply unlucky witnesses to cosmic diversity, that if enough comets wander in, eventually one will be odd, and another stranger still. Yet others wonder aloud whether diversity is the wrong word. Perhaps what we are seeing is choreography, a sequence designed not to comfort but to confront. And so the deeper puzzle remains. Are the rules of science failing us because the cosmos is more creative than we imagined? Or are they being bent deliberately, one law at a time, until we grasp that we are not the only ones who write them? If rules can be bent, then timing becomes the tool of choice. Atlas did not wander in casually. Its arrival traced a path so steep and so exact that it felt less like drift and more like choreography. Its perihelion date, October 29th, 2025, placed it just far enough from the sun to tease observation, but close enough to risk losing it in glare. A cosmic dance of reveal and conceal. Astronomers call these observation windows, narrow slices of time when a comet can be tracked before slipping out of sight. With Atlas, those windows were frustratingly thin. Hubble glimpsed it, Webb caught a spectrum. The Very Large Telescope traced its coma. And then darkness, as if the curtain dropped right after the overture. Some argued this was nothing unusual. Orbital geometry often conspires against us, but to others the timing felt deliberate, as though Atlas wanted to be seen just long enough to puzzle us, and then to vanish before we could decide what it was. A visitor leaving footprints at the door, but never stepping inside. And yet the geometry offered more than frustration. It offered suspicion. Its steep angle relative to the ecliptic plane looked like reconnaissance, a pass across our solar system that mapped rather than meandered. Coincidence, perhaps, or choreography again, which leaves us with the quiet question, was ATLAS's timing an accident of celestial mechanics or a demonstration of control? And if it was a demonstration, who was the audience? Us, or someone else entirely? For all the talk of trajectories and chemistry, the true story of ATLAS may lie in the humans who tried to interpret it. Astronomers are trained to measure, not to feel. Yet as Atlas slipped through its narrow windows, it stirred something more than data. A kind of unease, almost like being watched by the very thing you were observing. The official statements were calm, almost rehearsed. A comet, likely interstellar. Nothing to fear, those words echoed across press releases and interviews. But in the margins, in conference calls and quiet meetings, a different mood surfaced. Words like odd, anomalous, even unnerving crept into their notes. The world's most powerful telescopes, instruments designed to bring clarity, admitted defeat in whispers. Atlas's chemistry was the sore point. An 8-to-1 ratio of carbon dioxide to water. It refused to be explained away. For comets born in our solar system, water leads. Ice sublimates, tails flare, and carbon dioxide trails faintly behind. But here, water fell silent while carbon dioxide screamed. Some shrugged, calling it interstellar diversity. Others asked more quietly, what if the chemistry wasn't born, but written? That was where the paranoia seeped in. If Atlas wanted to be noticed, what better way than to violate expectations so cleanly? The thought was rarely voiced aloud, but it circulated like static. This comet was performing for us. And in that possibility lay a discomfort that science alone could not soothe. The irony was almost cruel. The more data they gathered, the less sense it made. The more instruments stared at ATLAS, the more it seemed to stare back. Humility replaced confidence. Paranoia replaced certainty. And in late-night conversations, astronomers admitted the truth. This object had not clarified our rules. It had broken them. So the watchers watched, and for the first time in years, they felt watched in return. A natural body, yes. Ice, dust, gas. But also an actor on a stage it should not have known existed. The question remained, who wrote the script? If Oumuamua was the opening act and Borisov the interlude, then Atlas felt like a finale that refused to resolve. Each of these visitors carried a puzzle, but Atlas seemed to turn the puzzle itself upside down. Oumuamua, discovered in 2017, bent our sense of shape and motion. Long, thin, like no asteroid we had ever catalogued, it accelerated just slightly without explanation. Gravity alone could not account for it. Some whispered of light sails, thin as foil, propelled by sunlight. Most settled for unusual rock, but even the safest explanations carried unease. Borisov in 2019 restored a measure of normalcy. It looked like a comet, icy, shedding gas, building a classic tale. But the normalcy was deceiving. No comet in our system had its exact composition. It was like meeting a familiar stranger, one who smiled the same way but spoke in a different tongue. And then came ATLAS. Unlike Oumuamua, it did not hide its activity. Unlike Borisov, it did not mimic the familiar. Instead, it shouted with chemistry that broke the script entirely. Carbon dioxide overwhelming water, ratios we had never measured before. It was not just strange, it was rule-breaking, a comet rewriting the chemistry books while we watched. That is why scientists spoke of it differently. Oumuamua was anomalous. Borisov was exotic. But ATLAS, Atlas, was described as confounding. A word that admits defeat. A word that admits we may not be holding the right key to the lock. So the sequence of visitors does not tell a neat story. It tells a broken rhythm. First shape, then familiarity, then rule-breaking chemistry, a drumbeat that grows louder with each strike. And if this is a pattern, then what comes next? 3 interstellar visitors in less than a decade. Statistically, that number alone unsettles the models. For most of astronomy's history, we believed such objects would pass through our system once in centuries, maybe millennia. But Oumuamua, Borisov and Atlas arrived like clock strikes, close enough together to make chance feel less convincing. Some researchers argue this is simply better detection. Our telescopes are sharper, our surveys wider, our sky maps fuller. Perhaps we are finally noticing what was always there, but others feel the timing is too perfect. Each arrival offered something different, as though staged. Oumuamua to challenge shape, Borisov to mimic familiarity, ATLAS to dismantle chemistry, 3 notes in a rising scale. If so, was the universe conducting the music, or was someone somewhere playing a quieter hand? The difference matters. In one version, interstellar comets are simply plentiful, drifting relics of distant star systems. In the other, the sequence begins to look like reconnaissance. Each visitor testing different rules, taking different measurements, probing different responses. Even scientists who reject conspiracy admit the statistics sting. Randomness is messy. Patterns, even faint ones, demand attention. When 3 visitors arrive so close together, each with its own rule to break, the mind resists shrugging it off. Was this coincidence or choreography, accident or intention? And so the questions lingered. Were we simply unlucky to meet 3 anomalies in quick succession? Or were we finally being allowed to notice a larger pattern, one that extends beyond our sky, beyond our science, perhaps even beyond our understanding? If the sequence of visitors was music, then their timing and geometry felt like choreography. Every interstellar object arrives with a script written not in ink, but in orbital arcs, paths dictated by gravity, yet uncanny in their placement. Oumuamua slipped through in 2017, almost invisible, leaving us with only weeks to glimpse it before it faded into the dark. Borisov followed in 2019, generous by comparison, its bright tail hanging in our skies for months. Then Atlas, in 2025, chose an entrance marked by narrow windows, too close to the sun for easy study, its most revealing moment occurring while Earth was hidden in glare, almost as if observation was not meant to be convenient. Astronomers call these observability windows. To scientists, they are frustrating quirks of celestial mechanics. To dreamers, they look like stagecraft. What are the odds that each visitor's most critical moment would line up with Earth in such awkward positions? Was this cosmic chance or cosmic discretion? NASA and ESA emphasized the natural explanation. Geometry is merciless, not mindful. Objects follow the laws of gravity, not intention. Yet unease crept in. A narrow geometry can feel like a closed curtain, hiding an act just as the audience leans forward. Atlas, in particular, seemed to lean into that curtain, its chemistry screaming anomaly while its position whispered, "Not yet." Geometry, then, is not just numbers, it is timing, opportunity, denial. And when 3 visitors in a row bring with them windows too tight, too fleeting, too conveniently obscured, the question shifts. Are we struggling against randomness, or are we being managed by design? If geometry was the stage, then the telescopes were the audience. Hubble, the veteran eye in orbit. Webb, the newcomer with infrared clarity. The very large telescope in Chile, rooted in desert silence. Each one turned its gaze toward ATLAS, each one trying to catch whispers before the curtain closed. Hubble recorded faint signatures, but even it strained. Webb saw what others could not. Carbon dioxide flooding the spectrum, water muted almost to silence. The very large telescope, with its immense mirrors, confirmed what Webb had whispered. And yet, even together, their vision was partial, fragmented, never complete. Scientists described frustration in calm voices, but beneath the language of precision was emotion, humility, awe, and a creeping sense of unease. The more advanced the instrument, the more it seemed Atlas kept secrets. Like a subject refusing to answer the right question, its silence spoke louder than its data. We anthropomorphize these machines because their limits mirror our own. Hubble could strain, Webb could whisper. The VLT could confirm. And together they confessed something human. Even with our greatest tools, we were staring at an object that refused to be simple. Was it arrogance to think we could trap an interstellar traveler in data alone? Or was Atlas deliberately designed by chance or by choice to remind us of our limits? That with all our reach, our instruments remain apprentices before a master. If telescopes were the watchers, then chemistry was the performer on stage. And Atlas did not give us harmony, it gave us dissonance. Where a normal comet sings with water, ATLAS sang with carbon dioxide. Not a little more, not twice as much, but nearly 8 times stronger. A ratio so lopsided that scientists blinked, checked their instruments, and then checked them again. If comets are archives of their birthplace, then this was an archive written in a dialect we had never read before. Water is the voice we expect. It evaporates easily near our sun. It paints tails across our skies. But here, water was muted, subdued, a background singer almost erased from the track. Carbon dioxide stepped forward instead, dominating the spectrum, as if declaring, "I am the headline here." Some said this was simply interstellar origin, born in a colder nursery where CO2 could freeze and linger while water remained locked away. But even that explanation carried unease, because if chemistry is environment, then why did ATLAS look less like a natural outlier and more like an intentional exception? What if this fingerprint was not just unusual, but engineered? NASA and ESA framed the anomaly as curiosity, not alarm. But outside press conferences, the whisper lingered. Chemistry does not lie. Ratios tell stories, and this one told us something we were not ready to hear, that either our models were too small or ATLAS was too deliberate, and so the chemistry became character. Water, the silenced witness, carbon dioxide, the loudspeaker. Together, a duet that broke the rules of our expectations. Together, a code that said, "Look closer." When you meet a stranger once, you can call it an accident. Twice, and you start to see a pattern. 3 times, and you wonder if it's a plan. Oumuamua startled us first. Long, thin, tumbling and accelerating in ways we could not explain. It refused to release gas or dust, and yet it moved as if something unseen pushed it along. A natural shard, perhaps, or something more deliberate. Then came Borisov 2 years later. It looked more familiar, icy, active, bright with water vapor. It was the textbook interstellar comet, reassuring in its chaos. Borisov fit our models. It let us breathe again. And then Atlas. Unlike Borisov's water or Oumuamua's silence, Atlas broke both molds at once. It was active like a comet, but not with water. Its carbon dioxide signature was extreme, its orbit steeper, its timing uncanny. It was as if it had studied the first 2 visitors and then chosen to arrive as their contradiction. Scientists tried to reassure themselves with context. Oumuamua was strange, Borisov was typical, ATLAS was just another outlier. But even they admitted 3 interstellar visitors in less than a decade was already suspicious. Before 2017 we had never seen one, now 3, each breaking different rules. If Oumuamua was silence, Borisov was noise, and Atlas was imbalance, then together they formed something else, a rhythm, a sequence of puzzles, each building on the last. And if that was true, then the question shifted. Were we studying objects, or were we being studied through them? Because Atlas did not just break the rules of comets, it broke the rules of coincidence itself. If the chemistry felt like a code, then the orbit felt like handwriting, because Atlas did not wander in blindly. It traced a path through our solar system that looked less like chaos and more like choreography. Its entry vector was steep, descending from the northern skies, slicing across the familiar orbits of Earth and Mars. The angle itself was unusual, so sharp that it stood apart from the slow, shallow arcs of most comets born in our own Oort cloud. Atlas entered as if aiming, not drifting, and then came the timing, perihelion, October 29th, 2025. A date that fell just as Earth slipped behind the glare of the sun, nearly invisible to ground-based observatories for a stretch of critical weeks. To catch it properly, we relied on Webb, Hubble, and spacecraft outside Earth's blinding shadow, as if Atlas had chosen a window when human eyes were most likely to blink. NASA reassured, coincidence, nothing more. Comets do not schedule their arrivals. And yet, astronomers knew that observation windows matter. Miss one, and whole layers of data vanish forever. The alignment was a reminder. Sometimes what you don't see matters more than what you do. So we asked, was this mere orbital geometry, or was it a form of reconnaissance? Because when the path of an object slices cleanly across the solar system, when its timing slips through blind spots, and when its chemistry whispers in riddles, the effect is less like chance and more like intention. Geometry was supposed to be neutral, numbers and ellipses on a page, but Atlas turned it into narrative, into suspense, into a clock ticking in the dark. In a story like this, the instruments become characters, because Atlas was not just observed, it was chased. Each telescope, each eye on the sky carried its own strengths, its own blind spots, and its own quiet emotions. Hubble strained first. Its vision, sharp but aging, could still carve faint streaks against the starfield. It gave us images of ATLAS that were crisp but incomplete, blurred by Earth's own shifting orbit. Hubble's view felt like listening through static. Then Webb. Positioned far from Earth's atmosphere, its infrared gaze caught the chemistry directly, and what it found did not soothe. Carbon dioxide swamping water, the ratio tilting far beyond what comet science considered normal. Webb delivered clarity, but clarity that deepened the unease. The Very Large Telescope in Chile added its voice, measuring faint signatures from the ground. Its data aligned with Webb's. The imbalance was real. It was not a trick of one instrument. It was the object itself. For the community of astronomers, this chorus of agreement was less a resolution and more a confession. Because when every telescope said the same thing, when each confirmed the same imbalance, the puzzle only grew stranger. It was as though the instruments themselves were whispering in chorus. We see it too, but we do not understand it. And behind those results were people, teams who had spent careers modelling comets, suddenly staring at ratios that bent their rules. Some admitted humility, others frustration. In conference calls, there was a tone not often heard in science, hesitation, not over the data, but over what the data might mean. So the telescopes spoke, but they spoke in riddles. They gave us precision, but not interpretation, detail without context, a clarity that only magnified mystery. In that silence, a new thought surfaced. Perhaps the instruments were not failing us. Perhaps they were telling us something exactly as it was, something we were not yet ready to accept. Even with Hubble's images, Webb's spectra, and the Very Large Telescope's ground-based confirmations, something was missing. Atlas had given us numbers, ratios, velocities, angles, but no meaning. It was like listening to a conversation where every word was clear, yet the language was unknown. In science, silence is often dismissed as background, the absence of radio signals, the lack of a clear pattern. But with ATLAS, silence became the message itself. Every telescope spoke, yet the comet refused to explain. It circled our models like a ghost, refusing to cross the threshold into clarity. Some astronomers described it as humbling, others admitted it was unnerving. The ratios were not ambiguous, the orbit was not in doubt, and still the story would not resolve. A pattern without purpose, a script without a translation. And so speculation began to fill the silence. Was this just the fingerprint of an alien birthplace? Chemistry written by stars far from our own? Or was silence itself the code, designed to leave us unsettled? Because sometimes in cosmic stories, what isn't said echoes louder than what is. NASA's official lines were careful, natural, consistent with interstellar comet expectations. But between those reassurances, hesitation slipped through. Even their qualifiers, likely, consistent, plausible, carried the weight of doubt. For the wider public, this silence was filled with imagination. Articles asked if ATLAS was a probe disguised as a comet. Forums speculated on surveillance. Writers compared it to stage magic. The trick so smooth you didn't notice your attention had been redirected. But in the scientific community, the silence was heavier. It was the silence of questions unanswered, of data without theory, a silence that pressed on every conversation like the pause after a question too big to answer. When science falls quiet, other voices rise to fill the gap, and Atlas left a silence big enough for everyone to step into. The cautious statements from NASA, meant to reassure, sounded to some ears like hesitation. Words such as likely, plausible, and consistent became springboards for speculation. For the scientific community, it was an exercise in humility. They knew the risks of saying too much, too soon. Better to understate than to fuel unfounded fears. But outside the observatories, that restraint took on a different flavour. To the public, hesitation looked like a confession. Conspiracy forums lit up within hours of Webb's first data drop. To them, the chemistry imbalance was not a puzzle of planetary birth, it was camouflage. To them, the trajectory through Earth's blind spot wasn't coincidence, it was intention. In their hands, the absence of certainty became evidence of design. And yet, even in the most careful academic papers, there was a subtle echo of the same unease. Unprecedented, unexpected, unexplained. Words that, while technical, carried the same undertone of wonder, and yes, paranoia, that fueled speculation in the wider world. Here lies the paradox. Scientists and conspiracy theorists, divided by training and method, were circling the same empty core, one circled with caution, the other with imagination. Both were searching for a story that could contain a comet that refused to follow rules, and so the question deepened. Was Atlas a mirror reflecting back whatever we most feared or most desired to see? If you believed in cosmic coincidence, ATLAS confirmed the universe was stranger than we thought. If you believed in hidden intention, it became the perfect candidate for a silent visitor. Atlas was not the first comet to carry more weight than its icy mass. Long before telescopes, before orbital mechanics, humanity looked up at streaks of light in the night sky and read them as messages. To ancient cultures, comets were not natural bodies. They were omens, warnings, or divine messengers. Each tale that swept across the heavens carried human fear and human hope. In China, comets were called broom stars, sweeping across the heavens as signs that dynasties might fall. In Europe, their appearance was woven into chronicles of war and plague. To the Maya, their fiery descent through the night symbolized celestial battles, the struggles of gods mirrored above. What is striking is not the details of each culture, but the pattern they share. A comet arrives unexplained. A story rises to fill the gap. That story reflects the anxieties of its time. In the 14th century, the Black Death was mirrored in a comet's fiery sweep. In the 20th century, Halley's Comet sparked fears of poisoned air, and in the 21st, Atlas has become a canvas for questions of surveillance, technology, and alien intention. Even with modern science, the reflex remains the same. We are storytellers first, scientists second. Data feeds imagination, ratios turn into whispers of hidden design. Trajectories become strategies, silence becomes a message. So perhaps ATLAS isn't only breaking scientific rules, perhaps it is breaking psychological ones too, reminding us that no matter how advanced our instruments become, the human mind will always fill the sky with stories. And maybe that is the rule that has never been broken. The rule that says the heavens are not empty. They are a stage, and every comet is a performance, waiting for us to assign meaning. For most of history, comets were judged only by their brilliance and their tails. Fear and wonder were written into fire across the sky. But Atlas was different. This was not a medieval omen or a whisper of the gods. This was the first time in human history that an interstellar visitor could be studied with the most advanced instruments we had ever built, Hubble, Webb, and the Very Large Telescope. And yet, Even with that arsenal of technology, what we captured was not clarity, but confusion. Every spectrum agreed. Carbon dioxide was dominant, dwarfing water vapor 8-1. But what that meant was anything but clear. Was it the signature of an exotic birthplace? A chemistry shaped in a region of space we had never seen before? Or was it something subtler, a signature not of place but of purpose? The irony is difficult to ignore. We had waited decades for another interstellar visitor, armed ourselves with the finest tools of science, and still found ourselves scratching our heads. The data flowed in, the certainty did not. Some called it progress. After all, a fingerprint is still a fingerprint, even if we don't yet know what hand left it. Others called it humbling, the realization that knowledge does not scale with technology as quickly as we hope, and a few dared to call it troubling. If an object can be measured so precisely, yet remains so opaque, what does that say about our ability to recognize something truly alien? This is what separates Atlas from the omens of history. We were not left only with fear or imagination, we were left with numbers, hard, undeniable, repeating numbers, and still the numbers whispered uncertainty rather than truth. So perhaps ATLAS is more than a comet, perhaps it is a test, a reminder that knowledge is not the same as understanding, that even with all our instruments, the universe still knows how to write mysteries just beyond our grasp. Knowledge is not the same as understanding, and nowhere is that more clear than when we compare ATLAS to the two travelers that came before it. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. 3 visitors, 3 puzzles, 3 rules broken in sequence. Oumuamua gave us the first shock, an object so elongated it stretched the limits of imagination. 10 times longer than it was wide. It accelerated in ways gravity alone could not explain, as though some invisible hand were guiding it. Astronomers argued, light sail, fractal ice, thin hydrogen sheet. None of the answers fit comfortably. Then Borisov arrived, more familiar, a true comet with a bright gassy tail. It looked ordinary, except it wasn't. No comet in our solar system carried its velocity. No comet came from interstellar space. Borisov reassured us by looking normal, but reminded us that even normal can be extraordinary when it crosses the stars to reach us. And then came ATLAS, not elongated, not textbook. Chemically bizarre, with carbon dioxide smothering water vapor. Its orbit cut steeply, almost theatrically, across the solar system. It was not just another data point. It was a contradiction, wrapped in a pattern. So the line of visitors raises a question. Was this progression random? A stone, then a comet, then something stranger still? Or was it a pattern? A slow escalation, a drumbeat of anomalies. What if these are not isolated accidents, but a sequence, each designed to stretch us further, to test our patience, our instruments, our imagination? And if that is the case, then Atlas is not just breaking rules of science, it is rewriting them step by step, as though the universe is teaching us a language we do not yet speak. If Atlas is rewriting the rules, then we are left with a troubling choice. Do we believe in coincidence or in escalation? Oumuamua, Borisov, Atlas, 3 anomalies in less than a decade. That alone bends probability. It is as though the cosmos waited in silence for billions of years and then suddenly began sending emissaries one after another, each stranger than the last. Scientists remind us that chance does not play fair. The universe is vast, the sampling window small. Perhaps we simply lived in the quiet centuries, and now we are living in the noisy ones. But others look at the rhythm, 2017, 2019, 2025, and wonder if randomness truly explains the pattern. Escalation is a different story. Escalation suggests intention, that each visitor is not merely a rock or a comet, but a test, a probe, a question hurled at us across interstellar darkness. The first, to open our eyes. The second, to reassure us that we were not mistaken. The third, to stretch our confidence until it snapped. Coincidence or escalation? Nature or message? The question lingers because both answers unsettle us. If it is coincidence, then the universe is stranger than statistics predict. If it is escalation, then something beyond us has begun a conversation we barely recognize. And perhaps that is why Atlas feels heavier than its icy mass suggests. Not because of what it is, but because of what it implies. That we may no longer be passive observers of the cosmos, but participants in a sequence unfolding with or without our consent. If escalation hints at intention, then the next question follows naturally. Intention toward what? A body as large and luminous as Atlas, cutting a steep path through our solar system, is hard to ignore. But what if the point was never to ignore it? What if Atlas was designed or selected to be noticed? A celestial mirror held up to us, not to light the sky, but to study our gaze. Astronomers have long spoken of reconnaissance in quiet tones. A probe disguised as natural debris would be the perfect observer, unthreatening, unchallenged, tracked only because our instruments demand it. And Atlas behaved with just enough irregularity to stir suspicion. A CO2 coma expanding disproportionately. A trajectory so steep it traced a survey line across the planetary orbits, a signal of geometry, if not of code. Skeptics argue there is no evidence of surveillance, no transmissions, no detectable propulsion, no instruments hidden in its icy dust. But absence is not reassurance. Silence can be a method. What if watching does not require words? What if observation itself is the message? In this frame, ATLAS becomes more than a comet. It becomes a lens through which we see ourselves, the way we scramble to track it, the way we debate its origins, the way suspicion creeps into every announcement of natural. Perhaps the test was not of our instruments, but of our reactions. And that is the unease that lingers when ATLAS drifts back into the dark. Was it a comet, or was it a watcher? And if it was a watcher, what did it learn about us? Our eagerness, our doubts, our fear. If Atlas was watching, then the next step in the thought experiment is unsettling. Was it also speaking? Not in the way we imagine messages. No radio pulse, no laser flash, no coded transmission buried in static. Instead, its voice may have been quieter, chemistry as syllables, trajectory as grammar, timing as punctuation, a story told not to our ears but to our patience. Consider the chemistry again. Carbon dioxide overwhelming water, nearly 8-to-1. Every comet in our solar system whispers water. Atlas shouted CO2. To a chemist, this is an anomaly, but to a storyteller, it is emphasis. The imbalance becomes not an accident, but an underline. What if the message was not hidden in a frequency, but in a ratio? Trajectory too may be more than a path. Its steep cut through planetary orbits drew a survey line, but perhaps also a sentence. Oumuamua's glide, Borisov's familiar arc, Atlas's sharp descent, 3 marks in a sequence. Coincidence or choreography? A quiet drumbeat, repeating until we notice the rhythm. Skeptics remind us, nature writes in oddities, not in tensions. Chemistry varies, orbits scatter, randomness explains more than conspiracy, and yet the feeling persists. When rules bend 3 times in a decade, doubt becomes difficult to dismiss. Silence too can be language. A pause can carry weight. An absence can be an answer. So if Atlas was a message, we are left with the uncomfortable question, to whom was it addressed? To us, fumbling with telescopes and ratios, or to someone else entirely, watching from further away? If Atlas was speaking, then perhaps we should consider the possibility that we were never the intended listener. Imagine standing in a crowded square, hearing a stranger whisper across the crowd. Not to you, but to someone else. You catch fragments, sense emphasis, but the meaning was never yours to hold. What if Atlas was the cosmic equivalent of that whisper? Its path cut through our neighborhood, but neighborhoods are shared. Mars, Jupiter, Saturn, their alignments during Atlas's passage drew lines of sight we couldn't ignore. At one point, Earth itself was hidden, screened behind solar glare, as if intentionally excluded from the angle of observation. Could that geometry have been chosen not for us, but for another watcher in the dark? The unsettling truth is that space is not empty. The silence between stars may conceal listeners we have never imagined, using methods we cannot recognize. If we are intercepting only the background noise of a deeper exchange, then our confusion makes sense. We were eavesdropping on a conversation that was never ours. And yet we cannot help but center ourselves. Every anomaly feels personal, every silence like an insult, every pattern like a sign. But what if this is our bias speaking, not the universe? What if Atlas was simply moving through, pausing just long enough to signal someone else, another civilization, another observer, another species that has been watching longer than we can imagine? We may never know, but the suspicion lingers, heavy as gravity. If Atlas was talking, then perhaps we were not the audience at all, only the bystanders, left wondering what words had passed us by. For centuries, science has carried a quiet assumption that if the universe speaks, it will speak to us. That if the stars hold a message, humanity will be the recipient. Atlas unsettled that narrative. To study its data was to face a humbling possibility that our instruments had picked up only the echo of a conversation never meant for human ears. For some, this realization bred humility. The cosmos, after all, is vast. Why should we imagine that every anomaly was scripted for Earth? For others, it sparked unease, even paranoia. If Atlas was sending signals past us to an audience unseen, then perhaps we were less the explorers and more the children, eavesdropping at the edge of an adult conversation. This tension shaped the way papers were written, how conferences debated, even how language was chosen. Terms like natural body and outgassing anomaly softened the edges of uncertainty, but hidden between the lines were doubts that the chemistry, the geometry, and the timing might not add up to randomness, that it was deliberate, that it was directed, just not to us. The effect was subtle but profound. Scientists who prided themselves on clarity began to hedge their words. Astronomers, trained to find order in orbits, admitted confusion. The world's most advanced observatories designed to deliver precision confessed defeat. Atlas had not just broken rules of science, it had broken the confidence that the rules were ours to keep. And perhaps that was the truest disruption. Not the chemistry, not the orbit, not even the suspicion of intention, but the reminder that humanity might not always be the center of the conversation, that the universe could speak clearly and we might still not be the ones it was speaking to. Oumuamua was strange, yes, but at least it gave us a puzzle we could sketch on paper. Its acceleration, unexplained though it was, could be modelled. Its shape, no matter how improbable, could be imagined. Borisov too had quirks, but they fell into a comet's familiar rhythm of ice and dust. Together, they formed a fragile expectation that interstellar visitors, however unusual, would still obey the grammar of nature. Atlas tore that expectation apart. It wasn't only the chemistry that unsettled, it was the timing. 3 visitors in less than a decade, when before we had seen none in centuries of sky watching. That sequence was too neat, too tight, too deliberate. Oumuamua hinted at the improbable. Borisov reassured us with the ordinary. But Atlas introduced the suspicion that both had only been opening acts, rehearsals for something stranger. The comparisons only deepened the disquiet. Oumuamua bent rules of motion. Borisov bent rules of rarity. Atlas bent rules of chemistry, timing, and even observation itself. Every telescope confirmed the anomalies, and yet not one could resolve them. It was as if the universe had staged an experiment. How many contradictions could humanity absorb before admitting it had lost control of the narrative? And so, Atlas became not just another entry in the catalogue of interstellar objects, but a disruption of the catalogue itself. If Oumuamua and Borisov had taught us to stretch our definitions, Atlas dared us to abandon them. A sequence that should have clarified instead dissolved into a riddle. Not one, but 3 interstellar visitors, each stranger than the last, each breaking a different rule. The pattern was broken. Or perhaps the pattern was only just beginning to reveal itself. If chemistry left us uneasy, and timing suggested choreography, then geometry turned that suspicion into something sharper. Atlas's path through the solar system wasn't a lazy curve or a casual drift. It was steep, precise, angled in a way that felt less like chance and more like intention. Astronomers mapped its course, plotting where it would shine, where it would vanish, and what worlds it would pass near. The diagrams looked less like the orbit of an aimless traveller, and more like the blueprint of reconnaissance. At its closest, ATLAS would skim past Mars, a near miss on a cosmic scale, but close enough to turn heads. Earth, meanwhile, was shielded by timing. When Atlas slipped past perihelion, its closest approach to the Sun, our planet was hidden from its line of sight, tucked safely behind solar glare. For a few crucial weeks, telescopes lost it, blinded by the star we orbit. A disappearance written not in science fiction, but in simple celestial mechanics. NASA explained this as normal. Comets often vanish when they swing too close to the sun, but the reassurance felt thin. For skeptics, the timing looked less like accident and more like design, as though ATLAS had taken advantage of our blindness, slipping through observation just long enough to deepen the mystery. The silence of those weeks became louder than the data itself. When the object emerged again, it was already receding, still puzzling, still unwilling to surrender its answers. Astronomers had expected clarity with more observation, but instead they were left with gaps, blank spaces where data should have been. The very geometry of ATLAS's journey seemed to hide what mattered most. And so the question grew larger. Was this just celestial coincidence? A path shaped by gravity and nothing more? Or was this careful geometry itself the message? A demonstration not of randomness, but of reach. For all the charts and numbers, astronomy is not a discipline without emotion. It is practiced by people, men and women who spend nights under domes of steel, chasing points of light that may never explain themselves. And Atlas tested not only their instruments, but their patience, their pride, and their humility. The Hubble team admitted that its aging optics could still see plenty, but even with its proven vision, the answers blurred. Webb's brand new infrared eyes confirmed the same chemical oddities. And yet, for all its power, it too felt like it was guessing at shadows. One astronomer called it like listening to a conversation through a wall. You know something is being said, but the words won't resolve. The frustration was not anger, but awe's uneasy twin. When an object refuses to yield to our categories, the human reaction is not just confusion, it is a creeping sense of being outmatched. Telescopes that once promised certainty now seem to hesitate, as if they too were aware of their own limits. The language in published papers began to change. Certainty gave way to softer phrasing, unprecedented, anomalous, not yet understood. In scientific literature, those words are not decoration. They are flags of humility, quiet acknowledgements that the universe has caught us off guard. And Atlas made those flags wave more than once. Yet there was something strangely comforting in that humility. For every frustrated calculation, there was a thrill, too. The recognition that discovery still lives, that space still holds cards we cannot read. It reminded scientists, and perhaps all of us, that the rules we write are provisional, that the universe does not play to our syllabus. And so the story of ATLAS was not just about a comet. It was about people, watchers at the edge of knowledge, whispering in their own way, if this breaks every rule we thought we knew, then what other rules are waiting to fall? When scientists confessed their humility before ATLAS, it wasn't because they lacked experience. They had faced strange guests before. In 2017, Oumuamua had already tested their categories, forcing them to ask whether a comet could accelerate without a visible tail. 2 years later, Borisov swept through, looking almost ordinary, an interstellar twin of the comets we had always known. Together, those two had drawn a rough map of what outsiders might look like, and then Atlas arrived and redrew the map entirely. Oumuamua, dark and stretched, had been a puzzle of shape and motion. Its strange acceleration still lingers in scientific debate, a question that refuses to close. Borisov felt like reassurance by comparison. Icy jets, dust clouds, chemistry we could recognize. If Oumuamua was the exception, Borisov was the reminder that rules still held. But Atlas rejected both templates. It wasn't shaped like Oumuamua, nor was it chemically balanced like Borisov. Its CO2 to water ratio, 8:1, ignored the patterns that billions of years of comet science had taught us. It was, in every sense, a body that seemed to say, the categories you made for me do not apply. This was the deeper frustration for astronomers. They could forgive Oumuamua's strangeness because Borisov restored the rulebook. But when Atlas followed, neither precedent was safe. What had seemed like exceptions began to look like a pattern, a rhythm of disruption, as though each visitor was a lesson escalating in difficulty. The very act of comparison became unsettling. If Oumuamua was geometry, Borisov was chemistry, and Atlas was intention, then what came next? Each seemed designed, not to repeat what we had learned, but to erase it. And so, the idea emerged. Perhaps it was not ATLAS breaking the rules. Perhaps it was our rules that were too fragile. Perhaps what we call science is only the local dialect of the cosmos, and ATLAS was teaching us to listen beyond it. If Oumuamua, Borisov, and Atlas were strange on their own, together they became something stranger still. The rhythm of their arrival felt less like coincidence, more like choreography. 2017, 2019, 2025. Each date spaced just enough apart to reset our expectations, just close enough together to keep the memory alive. If the universe was trying to teach us something, it was choosing its intervals with care. Astronomers are trained to dismiss patterns that seem too human, too tidy. Cosmic events, after all, scatter across billions of years and trillions of kilometers. But when 3 interstellar visitors appeared in less than a decade, even the skeptics admitted unease. What if this was not random distribution? What if it was a sequence designed to be noticed? Orbital geometry only deepened the strangeness. Oumuamua skimmed the inner solar system close enough to spark heated debate. Borisov swung past at a safer distance, but still bright enough for us to study. And then Atlas, timed for visibility, cutting across Earth's observational window at exactly the moment our most advanced telescopes were watching. Scientists reassured themselves these were natural interstellar wanderers, statistical flukes, nothing more. But the timing pressed back. Was it accident that Atlas appeared just as Webb was fully operational? That Oumuamua arrived when Pan-STARRS was tuned to faint, fast objects? Or were we, unknowingly, being given demonstrations at the very edge of our technological reach? It is one thing to study a visitor. It is another to feel as though the visitor has studied us. When events stack neatly in rhythm, the human mind struggles not to read intention. Was it chance? Or was it choreography? And if it was choreography, what dance have we just stepped into? If the sequence of arrivals felt like choreography, the details of each visit began to feel like reconnaissance. Oumuamua, fast and silent, slipped through like a scout, revealing almost nothing except the questions it left behind. Borisov followed with the opposite approach. Bright, loud, undeniably cometary, as if to say, see, not everything is suspicious. And then Atlas, carrying chemistry that unsettled our models, as though its message was written not in light, but in molecules. Each one gave us something different to measure. Oumuamua tested our ability to detect faint, fast objects. Borisov let us compare interstellar material to our own. Atlas forced us to re-examine the chemistry we thought was universal. Together, they formed a sequence that read less like accidents and more like a checklist: detection, comparison, confusion. This is not to claim intention where none exists. Astronomers remind us that nature itself can feel like a trickster, creating patterns that only look deliberate. But the more we study Atlas, the more we return to the same uneasy thought. What if we are not just watching, but being watched in return? Webb's infrared spectra confirmed the imbalance of carbon dioxide to water almost 8-to-1. Hubble verified the trajectory. Ground observatories filled in the gaps. If this was reconnaissance, it was designed to test our entire toolkit: optical, infrared, spectroscopic. Every instrument was drawn into the puzzle, each stretched to its limit. It is tempting to dismiss this as paranoia, to say, no, these are only natural visitors. But the cadence of their arrival, the escalating complexity of their mysteries, whispers another possibility: that each pass is part of a survey, that each question we cannot quite answer is itself the point. If reconnaissance was the first suspicion, the second was even stranger: communication. Not in the form of signals we expect, radio pulses, laser flashes, or coded beacons, but through the visitors themselves. Oumuamua's silence was its message, a kind of absence that drew us in. Borisov, by contrast, shouted familiarity, as though to reassure us with its icy plume. Atlas unsettled us by breaking the rules of chemistry, an imbalance that might as well have been punctuation in a sentence we couldn't yet read. This is not how humans imagined first contact. We built giant dishes, waiting for radio signals from distant stars. We launched records aboard Voyager, hoping someone would decode our songs. But what if the universe prefers slower methods? Visitors disguised as natural, drifting stones that leave behind puzzles instead of words. Every comet tells a story in chemistry: water, carbon dioxide, organics. Ratios that point to the environments where they formed. When Atlas revealed its unusual 8-to-1 carbon dioxide to water signature, Scientists saw only a challenge to their models. But what if that ratio was not just a signature, but a signal, a chemical whisper waiting for us to notice? It sounds far-fetched, and yet history reminds us how easily messages hide in plain sight. We carve meaning into stone tablets. We transmit binary from telescopes. Perhaps someone else encodes meaning in the frozen chemistry of a comet, trusting that one day another intelligence will notice the anomaly. If this is communication, it is not direct. It is ambiguous, patient, almost timeless. A message that unfolds not in words, but in the sequence of arrivals, in the widening gaps of our confusion. A message that forces us to ask, are we reading too much into coincidence, or are we only just learning to listen? If Atlas was a message, then the next unsettling question emerges. Was it meant for us at all? Human instinct assumes we are the center of the story, the intended recipients of every signal, but space rarely works that way. Comets do not bend their paths for human calendars. Their geometry is indifferent, their chemistry ancient. So if these interstellar visitors are carrying messages, perhaps we are only intercepting mail not addressed to us. Consider the timing. Oumuamua slipped by too fast to study, almost teasing our telescopes. Borisov gave us familiarity, but no chance to probe deeply. Atlas lingered longer, offering riddles in its chemistry, but still vanished into solar glare before we could catch all the answers. Each gave us just enough to wonder, not enough to conclude. That pattern could feel like poor luck, or it could feel like we were never the intended listener. It is not hard to imagine a galaxy where civilizations send signals not directly to one another, but into the void, like bottles tossed into a cosmic sea. Some wash up where they are meant to, others drift until they are noticed by strangers. If Atlas is such a bottle, perhaps we are not the conversation's partner. We are the eavesdropper. This perspective changes everything. It means that our confusion is not a flaw, but a feature. We cannot decode because we were never meant to. The chemistry that unsettles us might be as obvious as a return address to the real audience, and as unreadable to us as another species' handwriting. And yet, even if the message was never meant for Earth, its impact on us is undeniable. It forces us to confront our assumptions, that we are alone, that randomness rules, that every anomaly can be explained away. Whether accidental or intentional, whether ours to read or not, Atlas has left us unsettled. And sometimes being unsettled is the beginning of true awareness. If Atlas was not meant for us, then what happens when we treat it as if it were? Human history is full of examples where misread signals created chaos. A mistranslated letter, a misunderstood gesture, a wrong assumption, and wars have been fought over less. In space, the stakes are far greater, and the silence more unforgiving. Oumuamua, Borisov, and ATLAS each stirred imagination precisely because they defied our categories. Scientists called them natural, but with hesitation. Writers called them messages, watchers, even scouts. Between the two poles, certainty and speculation, anxiety thrives. If we misinterpret a comet's chemistry as intention or a trajectory as reconnaissance, we may project our fears onto the void rather than see it as it is. The philosopher Nick Bostrom once wrote of the vulnerable world hypothesis, the idea that certain knowledge once stumbled upon could endanger a civilization not prepared to handle it. Interstellar visitors may play a similar role. Their chemistry and geometry are facts, but the stories we attach are fragile. When paranoia fills the gaps left by uncertainty, even silence begins to sound like a warning. And this is the paradox of ATLAS. To ignore it feels arrogant. To overinterpret it feels reckless. Humanity is caught in a balance. Curious enough to search, anxious enough to fear, imaginative enough to invent motives where there may be none. If Atlas was a message never meant for us, then our reaction to it may reveal more about humanity than about the comet itself. The danger, then, is not in Atlas itself, but in us, in how we choose to interpret an anomaly that may only be passing by, in how quickly suspicion becomes certainty, and in how easily a cosmic coincidence can become, in our minds, the first move of a game we were never invited to play. If humans can stumble into disaster through a misread signal, what would that mean on a galactic scale? Imagine two civilizations separated by light years, trying to interpret one another with no shared language, no context, and no second chances. A flicker of radio noise here, a faint chemical imbalance there. What we call a comet, they might call a probe. What we dismiss as coincidence, they might see as choreography. The great astronomer Carl Sagan once compared interstellar contact to two children in different rooms tapping messages on walls. Simple patterns might be passed, but meaning is fragile. Now, magnify that fragility across cosmic distances and entirely alien biologies. Every signal is both a bridge and a trap. A misstep could mean nothing or everything. Atlas, with its bizarre chemistry, already tests our interpretive skills. CO2 overwhelming water, activity far beyond where we expected ice to behave. Is this the random fingerprint of its birthplace? Or could it be a coded marker, a flag planted in molecules instead of metal? If we assume one answer while another is true, our entire response to the universe could be based on error. And then comes the question we fear to ask. What if interstellar visitors are not mistakes, but deliberate gestures? Not designed for us, perhaps, but intercepted by us. Like overhearing a conversation not meant for your ears, our curiosity pulls us in. But what if stepping into that dialogue makes us a participant, even unintentionally? The danger of cosmic miscommunication is not just what messages are sent, but who decides what they mean. Scientists lean toward caution, conspiracy theorists lean toward intention, and dreamers lean toward wonder. The truth, if it exists, drifts somewhere in between, and in that gap, speculation grows. Perhaps Atlas is nothing more than a frozen traveller, breaking no rules except those we thought were universal. Or perhaps it is part of a dialogue we were never supposed to hear. Either way, the universe has placed us in the middle of a puzzle we don't yet understand. And misunderstanding on this scale could be more dangerous than silence. If Atlas is not just a traveller and not just a misread signal, then another possibility lingers in the background. Reconnaissance. The word alone feels heavy, borrowed from the language of conflict. But in astronomy, reconnaissance is simply the act of scouting, a quiet pass, a distant look, a survey of terrain. Could 3I/ATLAS be part of such a mission, whether natural or intentional? Its trajectory, steep and precise, almost looked like a cut across the solar system rather than a random plunge. Combined with its chemistry, a molecular imbalance no comet in our backyard has shown, the thought arises, is Atlas mapping us the way we map Mars or Europa? Not with rovers, not with orbiters, but with something subtler, a passing body that gathers information simply by being here, letting us react, letting us record. Skeptics remind us this is projection, nothing more. A natural comet can always surprise us with anomalies. And yet, history warns us of arrogance. Every time humanity thought we had the pattern locked, the cosmos revealed exceptions. Why not now? Why not with ATLAS? The reconnaissance hypothesis does not demand malevolence. It could be as benign as curiosity. A civilization somewhere scattering emissaries in the form of comets or probes cloaked as comets. Each one a test of our attention, a way to see if anyone is awake in this corner of the galaxy. If we are, then our telescopes have already answered. Yes, we noticed. But here lies the tension. If reconnaissance is the purpose, then we are no longer passive observers. We are participants in a dialogue defined by silence, chemistry, and orbital geometry. And once noticed, can we ever return to anonymity? If reconnaissance explains ATLAS, then another question follows almost immediately. Would one scout be enough? When humans map a new planet, we do not send a single probe and stop. We send waves. Voyager, Galileo, Cassini, Perseverance. Each one with a different purpose, a different angle of approach. So why should we imagine the cosmos working any differently? Already the rhythm of arrivals hints at something larger. Oumuamua in 2017, Borisov in 2019, Atlas in 2025. 3 interstellar visitors in less than a decade after centuries of silence. That acceleration alone should give us pause. Did we simply get lucky with timing, catching a cosmic parade? Or did the sequence signal a deeper intent? 3 notes in a melody still unfolding. Astronomers catalogue interstellar visitors as statistical anomalies, yet the numbers suggest more should come. Our galaxy is rich with debris, icy shards flung by other suns, but the clustering of recent arrivals feels different. Not random, but rhythmic, as though each object were not only a traveller but also a message in itself, a reminder that the silence between stars may not be empty after all. Of course, natural explanations abound. We have better telescopes now, wider surveys, sharper instruments. Perhaps we simply notice what always passed unseen. But the other possibility lingers. What if this isn't a new ability of ours, but a new activity of theirs? Not one scout, but a fleet, a series of tests, watching not just who we are, but how we react. And so the question expands. If ATLAS is one of many, how many more should we expect? Will the sky continue to deliver these puzzles at regular intervals, or has it already and we failed to notice? If 3 interstellar visitors can be seen as a sequence, then their timing and geometry must be more than background details. They are part of the puzzle. Astronomers know that space is vast beyond imagination, and yet, when mapped against time, certain alignments feel too precise to ignore. Oumuamua entered when our surveys were just becoming sensitive enough to catch it. Borisov arrived almost immediately after, so bright and active that it was impossible to miss, and Atlas, the third note, swept in during a year when both Hubble and Webb were free to point, record, and argue over its anomalies. Was that fortune or design? Astronomers explain it simply. Orbits intersect by chance, and when we improve our technology, we find what was always there. But there's another layer to consider. The geometry of Atlas's path was unusually steep, cutting across the ecliptic instead of following a shallow angle. This gave us weeks of close observation windows, exactly the sort of geometry a planner might choose if the goal was visibility, not obscurity. To some, that is the unnerving detail. A comet that behaves too much like a demonstration, one that enters at an angle ensuring we will notice, measure, and debate. Just as a magician tilts his hand to catch the light, ATLAS may have chosen or been chosen to pass where our instruments could not look away. So we are left with the tension: accident or choreography. If accident, the universe is simply teasing us with its timing. If choreography, then someone or something wanted to be seen. If geometry raises questions about choreography, chemistry deepens them into whispers of intention. When Atlas first revealed its spectrum, astronomers expected a familiar balance: water dominant, carbon dioxide and carbon monoxide trailing behind. That is the recipe of almost every comet we've known in our own solar system. But Atlas refused the recipe. Instead, CO2 overwhelmed water nearly 8-1, a ratio so lopsided it seemed to belong to another kind of kitchen altogether. In science, chemistry is more than composition. It is a kind of fingerprint. It tells you where an object was formed, what conditions shaped it, and perhaps even what histories it has endured. But in the case of ATLAS, the fingerprint smudged every comparison. No comet in our archives matched it. No planetary nursery we modelled explained it. It was as if Atlas were rewriting the chemistry of comets altogether. The safe interpretation is that interstellar objects form in stranger kitchens than we imagined. Regions colder, richer in carbon dioxide ice, deprived of liquid water. That is a plausible and natural explanation. But here, as before, a shadow lingers. What if the chemistry itself is not just a byproduct of formation, but a signature deliberately engineered? What if ratios can carry meaning, the way ink carries words? Astronomers hesitate to frame it so boldly. But the silence in their papers is often louder than their words. They list the anomaly. They admit the mismatch. Then they fall quiet, leaving readers to wonder. And so we ask, was ATLAS just a chemical curiosity, a natural byproduct of alien conditions? Or was it a message written in molecules, waiting for us to notice the imbalance? The more we studied, the less it resembled an accident. Each measurement added weight, not clarity. Each ratio felt less like noise, more like a deliberate arrangement. And if chemistry is the fingerprint of origin, then perhaps Atlas left us a print that was less about where it came from and more about who or what wanted us to read it. When we step back from the chemistry of ATLAS, the picture grows wider and perhaps stranger. For this is not the first time interstellar visitors have mocked our rulebook. Each of the three arrivals, Oumuamua, Borisov, and ATLAS, seemed almost designed to challenge a different assumption. Together, they form not just a sequence, but a pattern of defiance. Oumuamua broke the rule of shape and motion. It was long, thin, almost like a shard spinning erratically as if tossed into space. And when its trajectory bent ever so slightly without a visible cause, astronomers whispered about unseen propulsion, a light sail or something else we could not measure. Borisov, by contrast, obeyed expectations in form. It had a coma, a tail, the look of a comet, but it broke the rule of rarity. We had expected one interstellar object perhaps every few centuries, not another within 2 years. Its very presence forced us to rewrite estimates of how many wanderers drift between the stars and how often they pass our way. And then came ATLAS, not elongated, not ordinary, but chemical. It shattered the rule of composition, offering ratios that contradicted every comet we knew. If Oumuamua challenged physics and Borisov challenged frequency, ATLAS challenged chemistry itself. 3 visitors, 3 broken rules, each one eroding confidence, not with noise, but with clarity. And when rules fail in sequence, we must ask, is this the randomness of nature, or the rhythm of something larger, unfolding slowly, deliberately, in plain sight? Scientists, careful as ever, offer the cautious answer: coincidence, selection bias, the lottery of the cosmos finally paying out. But the thought lingers. If these were lessons, then each visitor was a chapter: shape, frequency, chemistry. What comes next? If Oumuamua broke the rule of motion, Borisov the rule of rarity, and Atlas the rule of chemistry, then together they broke another rule we rarely speak aloud, the rule of time. For the universe, vast and ancient, usually paces itself across billions of years, and yet, within less than a single human decade, 3 messengers appeared, each stranger than the last. The probability models had always been conservative. 1 interstellar visitor perhaps every few centuries, a second within living memory, almost unthinkable, and a third arriving just years later, carrying signatures no one could explain. That moved from improbable into the territory of suspicious. Astronomers wrestled with explanations. Perhaps our instruments had simply become sharper, our surveys more complete. Pan-stars, Catalina, Gaia, all now scanning the skies with relentless precision. Maybe visitors had always passed unseen, and only now were we learning to catch them. But suspicion lingered, because timing itself has meaning. In biology, in geology, in human affairs, clusters tell stories, epidemics break out in waves, revolutions arrive in bursts, and in the cosmos, patterns of timing hint at cycles, at orchestrations, at rhythms too subtle to dismiss. Was it coincidence that Oumuamua appeared in 2017, Borisov in 2019, Atlas in 2025? Or was this a sequence we were never meant to ignore? 3 acts in a play, staged for an audience that had just developed the tools to watch. Scientists reassured the public, random clustering happens, coincidences emerge, but the mind resists dismissal because when events align too neatly, they stop looking random and start looking intentional. And so the question remains, was this chance, or was it choreography written across the canvas of the solar system itself? If 3 arrivals feel like coincidence, then 4 or 5 would feel like choreography. That is the whisper running through astronomy circles, quiet, unspoken, but undeniable. Patterns matter in science. When data points cluster, they hint at laws, at causes, at unseen hands shaping outcomes. And so, when Oumuamua, Borisov and Atlas lined up across a handful of years, astronomers couldn't resist sketching lines between them. Each came from a different direction, each carried different chemistry, and yet each arrived while humanity's instruments were sharper than ever, like notes in a hidden melody, separated by silence, but played in tune. Was it chance or a composition? Skeptics pointed to probability again. The Milky Way is teeming with debris, tens of billions of rogue comets drifting between the stars. Statistically, some must pass through now and then. And yet, statistically, they should not cluster so neatly around the same decade. The odds bend under the weight of timing. Some theorists stretch further. What if these arrivals are not accidents of trajectory, but echoes of something larger, a cycle, a pulse, a kind of interstellar heartbeat we are only now noticing? If comets carry memory in their chemistry, then perhaps arrivals carry meaning in their rhythm. But even as telescopes continue to scan and software trawls the sky for faint streaks, the central unease remains. Were these objects always falling past us, invisible until our gaze sharpened? Or did someone wait until we were ready to watch? The choreography lingers, and the question sharpens. If the universe is performing for us, then what is the next act? If the geometry of ATLAS hinted at intention, the instruments watching it became part of the story. Not passive tools, but almost characters in a quiet drama. Hubble opened its eye first, old but steady, measuring brightness variations with the patience of a veteran. It confirmed what others suspected. A TLAS's light curve didn't settle into normal patterns. It flickered and shifted like something reluctant to be seen. Then came Webb, the new heir to cosmic vision. Its infrared gaze peeled back the comet's spectrum, separating carbon dioxide from water vapor, and what it found was unsettling. CO2 in overwhelming abundance, water almost absent, 8-1. Every line of data reinforced the anomaly. Webb, built to glimpse the earliest galaxies, suddenly found itself unraveling the chemistry of a local intruder. On Earth, the Very Large Telescope in Chile joined the chorus. Its adaptive optics struggled against the atmosphere, but its readings agreed. A TLAS was rewriting the rules. Observatories that had once spoken with confidence now sounded almost hesitant, their data delivered with careful pauses, as though afraid to overstate the obvious. The telescopes told us the same thing. A TLAS was different, but beyond the numbers, there was something human in their reports. Frustration at the limits of clarity, humility in the face of contradiction. The world's most powerful instruments were, in effect, admitting defeat against an object barely larger than a city. And here is where wonder takes root. Because if our greatest tools hesitate, if their readings converge on the inexplicable, what are we left with? Confidence or caution? Certainty or curiosity? The telescopes gave us facts, but the facts, stitched together, formed not an answer but a silence, one that asked louder questions than it resolved. The telescopes agreed on one thing: carbon dioxide dominated. 8 molecules of carbon dioxide for every one of water. In the language of comet science, this was like hearing a familiar melody suddenly played in the wrong key. Our comets, born in the Oort cloud or Kuiper belt, breathe water first and carbon dioxide second, but Atlas inverted the rulebook, as though its chemistry were deliberately out of step. On paper, this could be explained. Interstellar origins often mean colder births, further from a parent star, where carbon dioxide can freeze and persist while water remains locked away. Natural, yes. Plausible, yes. And yet, the imbalance was too precise, too consistent across instruments and across time. Webb, Hubble, VLT. Each found the same numbers. So scientists began to whisper, what if this wasn't nature's accident, but something closer to nature's disguise? Chemistry as camouflage, a ratio tuned to look wrong, just enough to spark curiosity without giving away the source. A fingerprint pressed into the cosmic ledger, but smudged in just the right places. Others were less conspiratorial, but no less uneasy. If chemistry is a record of origins, then Atlas seemed to be mocking that record. Was it born from a distant disk colder than any we've studied? Or was it, as some dared to wonder, engineered to rewrite the signature we expect, like a message scrawled in a language we almost understand, but not quite? This is where the line between science and story blurs. The ratios are real, the data is consistent, the anomaly is undeniable. But the leap, whether to natural oddity or intentional signal, is ours to make. And in that gap, in that quiet tension between evidence and interpretation, ATLAS becomes more than an object. It becomes a mirror for our paranoia, our imagination, our hunger to find meaning in silence. To understand how deeply Atlas unsettled astronomers, we have to place it beside its predecessors. Oumuamua in 2017 startled us with its shape. Long, thin and tumbling like a shard of cosmic debris. It had no tail, no coma, and yet it accelerated, faintly but undeniably, as if nudged by something we could not see. That broke the first rule. Comets should shed gas and dust when they speed away from the sun. Oumuamua refused. 2 years later came Borisov. Unlike Oumuamua, it behaved like a comet should. A bright coma, a long tail, water vapor and dust streaming freely into the solar wind. But Borisov was an outsider in every sense. Its speed and its trajectory proved it was born around another star. It broke the second rule. Comets were not supposed to be so easy to catch in transit between stars. Finding one should have been a once-in-a-century chance, yet here it was. And then, in 2025, came Atlas. Not tailless like Oumuamua, not ordinary like Borisov. Instead, it carried a chemistry that inverted expectations, a fingerprint that couldn't be matched to any model. If Oumuamua broke the rules of physics and Borisov broke the rules of probability, then Atlas shattered the rules of chemistry. Each visitor stranger than the last. Was this a progression? A sequence of lessons sent from beyond? Or was it only the randomness of the universe revealing its strangeness in bursts? The temptation to see choreography in this rhythm is almost irresistible. 3 arrivals, each rewriting a different page of the cosmic rulebook. Scientists, of course, leaned toward caution. Coincidence, they said. Natural variance. Nothing more. But even in their careful words was a trace of humility. The recognition that each discovery had blindsided them, and that Atlas especially seemed to arrive not to answer questions but to sharpen them. So here is the puzzle. 3 cosmic visitors, 3 rules broken. Was the universe teaching us something? Or were we being shown only what we were ready to see? 3 interstellar visitors in less than a decade. Oumuamua in 2017, Borisov in 2019, Atlas in 2025. On paper, that sounds like coincidence. But in astronomy, where the gaps between rare events are often measured in centuries, the odds begin to look absurd. Finding one such object should have been like spotting a single grain of sand drifting across a desert. Finding 3 in such quick succession? That feels like choreography. The mathematics alone are unsettling. If interstellar comets pass through the solar system this frequently, then our sky should be crowded with them. Dozens, maybe hundreds, on any given year. But telescopes do not show a constant rain of strangers. Instead, the arrivals come in pulses as though someone or something were striking a cosmic drum and we were only catching the echoes. Astronomers have tried to explain the clustering. Perhaps it is a matter of improved technology, wider surveys, sharper instruments, faster computers combing through data. Pan-STARRS, ZTF, and the Vera Rubin Observatory all make discovery easier. But better eyes alone cannot account for the strangeness of what those eyes have seen. Not just more visitors, but weirder visitors. So, is the clustering real? Or is it only our perception, sharpened by anticipation? That question lingers. Because if the universe has rhythms we do not yet understand, then perhaps these visitors are not just accidents of orbit. Perhaps they are part of a larger geometry, a hidden timing that shapes when and how they appear. NASA has been careful, always pointing back to nature. Debris shaken loose from distant systems, fragments wandering until gravity guides them past our sun. But even within those reassurances, there's hesitation, because coincidence is not a scientific category. It's a placeholder for what we can't yet explain. And so we circle back to the puzzle. Coincidence or choreography? Random chance or invisible design? With each visitor, the line between those explanations grows thinner. If coincidence begins to feel thin, then geometry is where suspicion deepens, because Atlas did not just wander in. It arrived on a path that carved through our solar system like a deliberate stroke, steep, angled and perfectly timed to skirt just within reach of our instruments. Perihelion came on October 29, 2025, when it passed at roughly 1.36 astronomical units from the Sun, a distance familiar, ordinary, but the timing was anything but. For nearly 2 months leading up to that date, ATLAS was lost in the solar glare. Our instruments had to wait, patient and half-blind, for the comet to re-emerge, almost as though its trajectory had been chosen to test the edges of our vision. This is the geometry of suspense, not danger, not collision, but concealment. Atlas hid behind the Sun at the very moment curiosity was sharpest. Then, when the geometry allowed, it returned, bright enough to tease data, dim enough to evade certainty. Astronomers reassured the public. Orbital mechanics explain everything. Objects fall inward, swing by the Sun, and retreat outward. But even within those clean equations, unease lingers. Because geometry is not neutral, it creates windows, and windows can be used. Imagine if an object wanted to watch, to observe quietly. What better way than to move in and out of sight with the natural rhythm of orbits? Long stretches hidden, brief moments revealed. A sequence that reads less like randomness and more like reconnaissance. Was Atlas merely obeying gravity? Almost certainly. But what if gravity itself becomes the cover story, a universal excuse beneath which intention can hide? That is the unsettling question the geometry leaves behind. And so we return to the same refrain. Nature or design, coincidence or choreography. The orbit is drawn in the stars, but the meaning is drawn in us. If the orbit tested our patience, the chemistry tested our understanding. When James Webb turned its mirror toward Atlas, the spectra came back with a stubborn truth. Carbon dioxide was not just present, it was dominant. Nearly 8 molecules of carbon dioxide for every one of water vapor. On Earth and in the comets we know best, water leads the story. Frozen lakes of ice, sublimating tails, the hiss of vapor boiling into sunlight. But here, water was strangely muted, as if locked beneath a crust, while carbon dioxide surged outward in abundance. It was a chemistry lesson that read more like a riddle. Scientists tried to explain it with birthplace theories. Perhaps Atlas formed far from its parent star, in a region where water froze too tightly to release, while CO2, more volatile, escaped more freely. It was a hypothesis that made sense, until it didn't, because even in the coldest cradles we've modelled, ratios this extreme remain rare, if not impossible. And so another pivot emerged. If chemistry is the fingerprint of an object's origin, then Atlas carried a print that looked smudged, human enough to recognize, alien enough to distrust. Was it natural ice, or a coded composition chosen precisely because it would look almost, but not entirely, normal? The world's most powerful instruments admitted defeat with quiet humility. Hubble traced faint water lines but could not reconcile the imbalance. Webb confirmed CO2 dominance but could not explain it. Even the Very Large Telescope whispered the same answer: anomaly. Natural explanations remained the official line: frozen chemistry, exotic birthplace, random chance. But for every reassurance, the unspoken question lingered. What if this chemistry was not just residue, but message? What if molecules themselves were arranged as symbols, a quiet drumbeat meant to be noticed by anyone listening closely enough? The silence of space leaves room for speculation, and Atlas, with its strange exhalations, left us wondering whether the message was hidden not in what it said, but in what it refused to explain. Atlas wasn't the first to bend the rules. By the time it arrived, the rulebook of interstellar visitors was already fraying at the edges. Oumuamua had started the unravelling in 2017, with its elongated shape and inexplicable acceleration, as if nudged by an invisible hand. Borisov followed in 2019, looking every bit the comet we expected, but its sheer speed and brightness still forced astronomers to admit it was not one of ours. Each visitor wrote its own contradiction into the margins of science. Oumuamua broke the shape rule, reminding us that our catalogues of cometary forms were narrow and naive. Borisov broke the rarity rule, proving that interstellar wanderers were not once-in-a-lifetime miracles, but perhaps a quiet drumbeat we had only just started hearing. And ATLAS, it broke the chemistry rule, forcing us to reconsider what frozen matter in the dark can or cannot be. Together they formed a sequence that felt less like coincidence and more like progression. First, a body that moved as if under hidden propulsion, then one that seemed familiar enough to lull us into comfort. Finally, one that tilted its chemistry toward the impossible. It was almost like an escalation, each visitor taking us one step further away from certainty. Scientists tried to stitch the narrative into coherence. Perhaps Oumuamua was just an oddly shaped rock, its acceleration caused by outgassing too faint to see. Perhaps Borisov was a lucky catch, a rare comet that happened to wander through our system while we were watching. Perhaps Atlas was simply the result of exotic birthplace chemistry. Each perhaps sounded plausible in isolation, but strung together they felt less like reassurance and more like excuses. Because if science is a rulebook, these objects were erasing lines faster than we could rewrite them. And if patterns matter, and in astronomy they always do, then 3 anomalies in under a decade may not be a fluke at all. They may be a signal, growing louder with each arrival. The question that lingered was not just what these objects were, but why now? Why would the cosmos, silent for billions of years, suddenly flood our skies with puzzles we cannot solve? If the universe is vast and ancient, then timing should be its most forgiving feature. Billions of years, endless orbits, countless chances. And yet, for us, the window of these arrivals has been impossibly narrow. Oumuamua in 2017, Borisov in 2019, Atlas in 2025, less than a decade, barely a heartbeat in cosmic terms. Astronomers tried to comfort themselves with probability. Yes, interstellar comets must pass through all the time. We simply lacked the technology to notice them before, but even with that explanation, the cadence unsettled many. Why would 3 such objects line up so neatly with the dawn of our best instruments? Was it luck, or was it choreography? The James Webb Space Telescope launched in 2021, just in time to catch Borisov's afterglow and Atlas's chemistry. The Vera Rubin Observatory, nearing completion, promises to find dozens more. Technology is rising, awareness is peaking, and suddenly the cosmos chooses to send us visitors. Coincidence is easy to say, harder to believe. Skeptics insist it is selection bias, a trick of perspective. We notice because we can, nothing more, but whispers remain, even among careful scientists. What if the universe is not random in its timing? What if these objects arrive not simply because they must, but because we are here to see them? 3 interstellar visitors clustered around the rise of human astronomy, each demanding questions we cannot easily answer. Was the timing natural, or was it tailored? If 3 arrivals feel like coincidence, then 4 or 5 would feel like choreography. That is the whisper running through astronomy circles. Quiet, unspoken, but undeniable. Patterns matter in science. When data points cluster, they hint at laws, at causes, at unseen hands shaping outcomes. And so, when Oumuamua, Borisov, and Atlas lined up across a handful of years, astronomers couldn't resist sketching lines between them. Each came from a different direction, each carried different chemistry, and yet each arrived while humanity's instruments were sharper than ever. Like notes in a hidden melody, separated by silence but played in tune. Was it chance or a composition? Skeptics pointed to probability again. The Milky Way is teeming with debris, tens of billions of rogue comets drifting between the stars. Statistically, some must pass through now and then, and yet statistically they should not cluster so neatly around the same decade. The odds bend under the weight of timing. Some theorists stretch further. What if these arrivals are not accidents of trajectory, but echoes of something larger? A cycle, a pulse, a kind of interstellar heartbeat we are only now noticing. If comets carry memory in their chemistry, then perhaps arrivals carry meaning in their rhythm. But even as telescopes continue to scan and software trawls the sky for faint streaks, the central unease remains. Were these objects always falling past us, invisible until our gaze sharpened? Or did someone wait until we were ready to watch? The choreography lingers, and the question sharpens. If the universe is performing for us, then what is the next act? When astronomers first mapped the orbits of interstellar comets, the temptation was to compare them to tides. Just as the ocean rises and falls with the pull of the moon, perhaps the galaxy itself carries unseen rhythms. Giant structures, spiral arms, stellar nurseries, gravitational waves could sweep debris along, nudging it into paths that cross ours. If so, then Atlas, Borisov, and Oumuamua might not be accidents at all, but expressions of a much older cycle. Every few million years, Earth passes through different regions of the galactic disk, some dense with stars, some quieter. Could those passages stir hidden reservoirs of comets, releasing them like dandelion seeds on a cosmic breeze? If that were the case, then what we are seeing is not choreography, but inevitability. And yet, inevitability does not erase curiosity, because if cycles explain their presence, they do not explain their timing. Why now, when our telescopes are finally capable of tracking them? Why not a century ago, when they would have passed unrecorded? It feels in some ways like watching a clock strike the hour just as you happen to glance up. Was the clock always ticking, or were you meant to look? This is where speculation sharpens into something more unsettling. If natural cycles cannot fully explain the clustering, then the alternative is more deliberate. Signals, not radio, not light, but motion itself. Objects moving along predictable arcs, as though someone or something were using celestial mechanics as a language written not in sound, but in timing. Some scientists dismiss this outright. They point to probability, to chance, to the billions of comets unseen between the stars, and yet others whisper, if we stumbled across Morse code in the sky, would we even recognize it, or would we dismiss it as random noise? The puzzle remains open. Were these arrivals echoes of the galaxy's tides sweeping us into a larger cycle? Or were they intentional strokes on a cosmic canvas, a message so large we cannot yet read it? If Atlas were a signal, the uncomfortable truth is that humanity does not have a perfect track record of reading the universe correctly. In fact, history suggests the opposite, that our first instinct is often to misinterpret. When pulsars were first discovered in 1967, their rhythmic radio pulses were so regular, so precise, that scientists nicknamed them LGM, little green men. For months, some wondered if these were alien beacons, only to learn later they were the steady hearts of collapsed stars rotating with metronome precision. And yet, the lesson of the pulsars wasn't simply that we were wrong, it was that the universe can produce signals so clean, so uncanny, that even seasoned astronomers can mistake them for intention. In other words, the boundary between natural and artificial is thinner than we like to admit. Then there was the famous "wow" signal of 1977, a 72-second radio burst, narrowband and powerful, captured by Ohio State University's Big Ear telescope. It never repeated. It never explained itself. It left only a handwritten exclamation in the data margin, "wow." Decades later, we still debate whether it was a passing comet, a satellite reflection, or something more deliberate. History repeats this tension again and again. First comes the pattern, then the speculation, then the retreat into safe explanations. But the unease never disappears, because deep down we know that the signals could have been more than noise. And in that knowledge, or lack of it, lies the mirror for how we see Atlas. Atlas may be natural, it may be nothing but ice and rock, but like the pulsars, like the wow signal, its timing and its chemistry are just precise enough to unsettle, to make us pause, to make us whisper, if only to ourselves, what if this one is different? Perhaps we are misreading, projecting meaning onto randomness, but perhaps we are not. Perhaps the real mistake is assuming that the universe speaks only in the ways we already understand. If Atlas is a message, then maybe the hardest thing for us to accept is this: we might not be the audience. For centuries, humans have placed themselves at the center of every story. We assumed the stars revolved around our world. We assumed any signal, if it came, would be addressed to us. But what if we are only bystanders, listening in on something never meant for our ears? Astronomy has shown us that interstellar space is not empty. It's threaded with molecular clouds, streams of dust, and magnetic fields that stretch across light years. What if comets like Atlas are couriers, crossing these spaces not at random, but along routes of communication we have yet to map? Imagine a civilization millions of years older than ours, sending signals not through fragile radio waves but through durable physical messengers, comet-like objects seeded with anomalies that another civilization would instantly recognize. Chemistry as code, orbit as signature. To them, the imbalance of CO2 to water might be as deliberate as ink on paper. We, of course, interpret through our limited lens. We call it strange but natural. We argue over whether it's cometary or constructed. But what if the real story is unfolding between others, and we are simply eavesdropping? A child overhearing fragments of an adult conversation, not quite understanding the stakes. Some scientists have even speculated about the idea of galactic archaeology, that space may be filled with artifacts or signals meant not for us, but for peers in a cosmic network. We are late to the party, stumbling into the dance floor just as the music begins to fade. Atlas might be one of those echoes, part of a dialogue older and larger than our species, and so we are left with the unsettling possibility, not that the universe is silent, but that it is speaking all the time, and we are not the intended listener. Atlas may not be a message to Earth at all. It may be a message through Earth, a whisper in a language we can't yet translate. If Atlas is not a courier, then perhaps it is something even stranger, a checkpoint. Not a message meant to be read, but a test meant to be passed. In the long silence of the cosmos, maybe civilizations are not greeted with broadcasts or welcomes. Maybe they are measured by whether they notice the anomalies drifting past. This idea unsettles astronomers because it reframes discovery itself. We thought we were the observers, the ones shining light into the dark. But what if Atlas is the observer, and we are the ones under the lens? Its precise orbit, its unusual chemistry, its timing, All could be markers not of natural chaos, but of deliberate calibration. Consider this. Every time Atlas crossed the gaze of Hubble, Webb, or the Very Large Telescope, it recorded our ability to look, to measure, to question, to doubt. If intelligence beyond us seeded these objects, then our reactions, the papers, the debates, the hesitations, become part of the experiment. And here lies the most chilling twist. A courier passes a message, but a checkpoint implies a threshold, a pass or fail. The possibility that civilizations are quietly filtered not by war or disaster, but by whether they are capable of noticing the test in time. Perhaps Oumuamua was the first trial, Borisov the second, Atlas the third, each harder than the last. We don't know what happens if the test is failed. Maybe nothing at all. Maybe silence continues forever. But if the test is passed, what then? Does the universe finally answer, or does it simply mark us as ready to be measured again when the next visitor arrives? And so Atlas leaves us with a paradox. It may not be a comet to study, but a mirror held up to us. Its rules broken not to confuse, but to reveal whether we are capable of seeing rules break at all. A checkpoint, drifting silently past, asking no question except one. Were you watching?